Cost, cost, cost. This is probably the biggest question we get when we tell people we're printing hundreds of thousands of parts. They say, how do you effectively compete with injection molding? Well, when we started Merit 3D, we had three major objectives to get over. So the first one was the cost of injection molding parts, the quality, and the scalability cost. So they have to be inexpensive, just like injection molding parts. The quality has to be just like injection molded parts as well. And the scalability, many parts very, very quickly. Today, Merit 3D primarily does SLA or resin prints because we think this has the best opportunity for growth to compete with those three levels. And in this video, we'll show how the part cost of resin compares to parts done in injection molding in mass production. So we deal every day with customers who are trying to decide between additive manufacturing and injection molding their products. It sometimes can be a very difficult decision. So to be clear, our focus is mass production, not doing prototype volumes. Each method carries its own set of advantages and disadvantages, particularly when it comes to cost considerations. Cost is always a big deal for our customers. We are competing in the injection molding world, so we have to be competitive. We'll explore some of the good, the bad, the ugly when it comes to mass production and additive manufacturing, and why the costs are what they are today. One of the biggest factors are molds, a big expense. Most companies amortize the cost of their molds over time and compare the total cost of the mold and the parts to the total cost of the additive manufactured parts, and they make their decision from there. Molds have been around since the 1800s, and we know that once a mold is built, the changes available are very limited. We've seen mold prices increase as people tell us that the art of mold making is not as common as it once was. Molds are usually only made when there are large volumes of parts to be made. Companies typically only use 3D printers for just the prototyping process. Well, additive eliminates the cost of molds. Digital design allows for layer by layer production, eliminating any molds. At our sister company, Dustless Technologies, we're always looking at the project to see if we can eliminate any molds. That eliminates a big cost up front and also eliminates design rigidity in the future. Without molds, it allows us to release a product much faster. After the cost of the molds, it's material costs. They're the next biggest factor. Today, these materials are more expensive than pellets, like pellets used in molding, but the materials are continually getting less expensive. Here are some of the numbers. Photocentric has resins that are more expensive and durable, but they just released one that is 19 euros a kg. That's like $9 to $12 a pound. You can see that prices are coming down. Companies like Loctite, BASF, Frozen, and many others are innovating in this space to get great qualities at a lower price. The prices are comparing to thermoplastics. Your nylons, your polycarbonates, your ABSs, polypropylenes, all of them when you buy them in bulk, they're between $2 and $10 a pound. So what will it take to bring material prices down? Many more people jumping into additive manufacturing for mass production. We buy some of these materials by the metric ton. And we have asked our material suppliers, what will it take to get the prices similar to injection molding? And they said about 100 tons a year for the first big drop. Economies of scale haven't even kicked in yet. The tough or durable and specialty resins require certifications. They'll follow. More adoption is needed as well. 3D powder prices are about the same price as resins, and filaments are much less because they use thermoplastics, which are already a commoditized item. You just have to decide if the quality and scalability meet your needs. Our goal is to get the 3D resins in a similar price range so we can bring more value to the table for our customers. Today, prices are about 4 to 5 times the cost of thermoplastics. So if you're going to mold this bike metal, it would be $10,000 to $20,000 for the mold to get a 75-cent part roughly. If you're going to 3D print it, you could go straight to production and it would be $2 to $3. You can then ceramic coat it and you can give it color, which adds more expense, and then you're in the $3 to $4 range. It happens that this design can't even be molded, and so it doesn't even matter. New innovations in resin are happening monthly to drive costs down while maintaining performance. Stronger, lighter, cheaper, economies of scale will continue to get better. Third is you can design to reduce costs. One of the methods to reduce costs is to design it with little or no material waste. Molds have to be made in a way that the two halves pull apart. The more complicated a mold is with sliders or threads, the more costly the mold is. But because thermoplastics are so inexpensive, designers really don't care if they use extra raw goods in a part because they're so inexpensive. Added intricacies and complexities are an added bonus with additive, because if it's designed for additive, it will print great either way. So this part, take for example, is a vacuum accessory holder. It has a lot of plastic on it. This could possibly be designed differently using less material and still serve the same purpose, reducing the cost of raw goods and the overall cost. Fourth is designed to reduce the assembly costs, reduce the number of parts by combining the features. These promotional pens are mostly made in China, and the process is mostly automated. No one is touching each pen. Not much innovation in that space today because it's a very commoditized item. Look at how many parts go into this pen. And if it were assembled by hand, it would be a pain. Each component has a mold, it has inventory. This pen we designed has 4 components. We designed it differently. We combined different features to give it added value in the simplification of assembly and at the same time make it cool. Now, we just need the automation part. I know you're saying, why would you design a new promotional pen? Well, because it's made in the US and because people said we couldn't do it. The slurry vacuum float is another. It went from 12 components to 2 components, reducing assembly time by 600%. This hanger was designed to take the place of 3 different molds. When you have an order of over 1 million of these, it's critical to reduce inventory. Creating a design that was universal was a big win for additive here. Design is huge. 5th point is speed to market. If you're doing the work yourself, or if you have a team that works with you, time is money. So the sooner you're able to launch a product, the faster you can get an ROI on that project. At our sister company, Dustin Technologies, and many other companies, it typically takes or took 18 to 24 months to launch an injection molded product. Many of you are faster than us, and that's okay. It took months to get a prototype, months of testing. It took months to build a mold, months from parts from China, months of outside testing, months for molds, for mold changes, for further testing, for weeks for more mold changes, and a lot of time waiting. And especially when COVID hits, then you have months of inventory sitting on the water. So supply chains are real, and it compounds when you have inventory overseas. The thing is, if you can go from 18 months to 4 months, you can release 4 times the products and you don't have to pay for molds. Quicker ROI, and start your next product sooner. The 6th point is size of parts. Additive for us and for many other technologies is the more parts you can make per batch, the less expensive it is. Parts that are the size of an apple or smaller are great for costs. We can arrange them, and sometimes we can nest them. We can just print a ton of parts and drive your cost down. With smaller parts, we can compete with injection molding on cost much closer today. This is a GoPro mount. The mold is between $7,000 and $15,000. In-house or with good connections, you can probably get it for a lot less. Parts in the mold are 30 to 40 cents is an estimate. 3D parts are between 90 cents and $1.25, a little more than double the price, but you have to buy 25,000 to 30,000 pieces to break even on the mold. Grapefruit sized parts are a little more expensive. Parts the size of this temple, this is hollowed to save on material. but a mold this size is going to be between 13 and 20,000. Parts from the mold are going to be between $2 and $3 roughly. 3D parts are between $8 and $10. You need 4,000 parts to break even with the mold. This is a binocular tether. We had 2.4 of these coming off the printers every second. This one is a little bit tricky because this design can't be molded. We produced over 60,000 of these in one day. To have a mold at a 45 to 60 second cycle time, you would need a 149 cavity mold to keep up with how fast we were 3D printing these. A 149 cavity mold with sliders would be between $200,000 and $400,000. This would be a 5-cent part off the molds, where the 3D part was a 10 to 12 cent part. And so you would need literally 5 million of these parts to break even with the mold. You can't even mold this, so it doesn't even matter. Because of the 3D printing technology, the larger the part, the more exponential the cost of the part. The flip side of this is big injection molds are much more expensive than smaller ones. This vacuum right here, the molds for this vacuum in the 90s, built in Taiwan, then shipped here to Utah, were $750,000, well over $1 million today. We can do much larger parts, but that is a different ballgame today. For our process, as we are set up for mass production, it takes us the same amount of time for one great part as it does for thousands of parts. Our pricing model is, if you want a small run, then the per piece price is higher. Once you start getting over 500, 1,000, 5,000 pieces, the price starts to drop dramatically. But one big advantage is you don't have to buy loads of parts. You can reduce your inventory holding costs by having on-demand parts and just-in-time shipping. Transportation costs. Because equipment is getting more affordable, reliable, and accessible, one of the potentials of additive manufacturing is microfactories become closer to home. This will significantly reduce transportation costs for manufacturers overseas. What about post-processing costs? One factor that drives injection molded costs down is the automation that has been developed over the years. Machines pull parts from the molds, they do any trimming, they put them in a box. Because 3D mass production is so new, this has to evolve. And it's going to evolve in 3D. And the savings on labor will or should be naturally passed down to you. We expect this to start accelerating much faster in the next 2 to 7 years as more companies get into the digital mass production and mass production workflow. Another factor is that 3D printers are higher maintenance. There are so many variables on a printer, they're getting simpler and more reliable each day, but it's still easy to mess something up. Consistent innovations are helping improve this and will help drive prices lower. Some factors of additive manufacturing over injection molding are very hard to measure. It's hard to put a cost on the agility of additive manufacturing. How do you measure the ability to improve a design so simply? Even able to improve the smallest thing like increasing wall thicknesses or increasing the fit of a part. Another is the holding cost of capital. You don't have to pay inventory from coming overseas and prepay for it. Another is just-in-time inventory. You can have it right now when you want it. You don't have to order thousands at a time just to sit on your floor. We see this market growing every day. Our philosophy is knowing that this market is growing, that economies of scale are getting closer, that automation is growing, that material properties are getting stronger. It just motivates us to adapt to the new technologies. Others will follow, but the key is to find what works for you and to run with that, knowing that it will just get better. The key is to try to find something and not give up. If the cost or the quality are not what you need it to be, then try a different material. If you have any projects you would love to work with us on, want to send us a part, would love to see if we can help you. Thanks.